Hello. We're going to talk today about functional programming anti-patterns in Java. Stuff that we can do to make the code worse with the most recent and most shiny and bright new features of Java language. My name is Rentea. I'm a Java champion. I have 18 years of coding, and for the past 10 years, I've been doing workshops and consultancy for various companies throughout Europe. My main topics are these: refactoring, architecture testing, also frameworks and performance and secure coding. By the way, very nice talk before that. I wanna subscribe. I wanna get that plugin myself. It's something very interesting. I must confess. I have a community that I will invite you to join. European software crafters community, the largest community in the world, concerned about how to write code that the ones maintaining it won't hunt you down afterwards. So writing maintainable simple code. We meet every month for 1 hour at starting 5 p.m. Central Europe time. If you want to join, you can find past events recorded on my YouTube channel. Besides that, life's complicated, but we are doing our best to serve the community. So, functional programming in our daily life. Let me just set up a little timer here. So yeah, I have 30 minutes. Functional programming in daily life, in our life. What did it change? First of all, we're talking about strictly Java today, right? So in our daily life, when functional programming came in Java 8, it allowed us via some syntactic sugar to be able to pass around behavior in our code without having to follow up with an object that wraps around that behavior. So it's just simplifying the passing a function around. Functions are first-class citizens, you might have heard. Then it greatly simplified the way we work with collections. We don't need to change collections anymore. We don't need to add or remove from collections. We can just filter map to list to set, grouping by, and we get the results without ever changing collections anymore. But that's just the surface of functional programming. That's just that meets the eye. That's just the stuff that the stuff that impacts our daily life. But the philosophy of functional programming goes far beyond that. Functional programming is all about having data which is immutable and having functions which are pure. This is an interview question, by the way. And the pure function should not be changing stuff around and should return the same result for the same input. In other words, it's a fancy word, pure function. So technically, functional programming means programming without side effects. That's the philosophy of functional programming. Don't change, return. All right. Let's first talk about immutable objects and how we can get these wrong in Java. So it is, let's say, quite well known today that mutable state is bad. Why? Because if it lives for too long, it runs the risk of you passing it in places, in dark corner of your logic, that will end up changing it, not by accident, but by trying to do a dirty patch, a dirty hack in the dark night. One day, someone sets a field in a function which runs 7 layers deep in your complexity, and that's very hard to trace. Who changed that field and why and when? Another moment in which mutable data is going to get you into trouble is when we play with multi-thread. When we play with multi-threaded code, with concurrent code, we can have race conditions because of changing data in the wrong order, randomly mutating over each other. Now, because of this, we want to go to immutable objects, but immutable objects, they don't come for free. We are in Java, so probably the most widespread way to persist data today is GPA, right? Using an ORM, using Hibernate. And if you try to mix immutable objects with Hibernate entities, all the teams I ever met, and I met hundreds of teams. This is what I do every day. I talk to companies. Today I went for a training at a major telecom company in Romania. And they were also using GPA. Every team that I met, which tried to make their Hibernate entities immutable, they regret that. Don't try that. You can make your embeddable object immutable with no problem. You can make your Mongo document immutable, no problem. But don't try to make the entities immutable. Please, I beg you. You will suffer. Also, be careful with repeated cloning. From a language which I have very dear to my heart, Kotlin, in Kotlin, the collections are by default immutable. So in Kotlin, they got burned one day. They did this. So they actually started with an immutable list, which was immutable, and they did a fold, which is a kind of a reduce. And when you fold an immutable list and you add to an immutable list a new element, this plus over here results in cloning the list, creating a new immutable list with the new element added at the end. And this results in a lot of memory churn, in a lot of memory pressure, allocating new objects, right? This actually, with the profiler, returned into allocating 400 megabytes for a list of 5,000 elements. 5,000, not more. 5,000 elements allocated 400 megabytes. So if you clone immutable objects in a list, you can get burned by allocating too much memory. Especially collections are dangerous. But this is, profiling is going to show this. Life is going to show this. But there is one more thing that can get you into trouble. Designing your immutable objects too large. I find this is a bad practice. First of all, the first problem when you have a large immutable object is that your constructor is going to be ugly. Now we know how to fix this. We've long been using Builder, right? With Lombok or without. But that is just the way to hide the ugly constructor. Right? By the way, other languages don't need builder because they have named parameters. Still, the thing I'm annoyed with is the use of toBuilder. You see, you can have an object, immutable object coming in, large object, and you might want to change A and B. There is a hack you can do with Lombok. You can ask it to create you a toBuilder method, which would create for you a builder pre-filled with the state in the original object, so that you can hack it in the way you want. What's wrong with that, you could ask? I don't like the idea of being able to randomly change any field without any kind of semantics behind. Just randomly treating data just like pile of fields. I hate that. I would prefer to have methods which are more smart with full name, which ask you to pass the two strings that represent the full name. Maybe A and B were first and last. Why not making a method which is more semantic rich? Or maybe even you can discover new value objects, new types. Maybe you could just discover that you would benefit from creating a class named full name or a record named full name. So you see, Builder tends to hide these ideas from you. You can just fall into a mindset of randomly treating data like a pile of fields. I don't really like that. I don't really think this is going to get you better code. I've seen places in which a new type would have simplified so much code, right? So don't make your immutable objects too large, and be always on the lookout for grouping new objects out, extracting new objects, or making more semantic rich methods inside your. I'm gonna jump over this. This is not really functional programming. Second, there. 4. What's wrong with 4, you could ask? Well, 4 in 2018, December, was labeled as being a code smell by what I call the New Testament of clean code, which is the refactoring second edition by Martin Fowler. They actually included 4 in the code smells chapter. 4 is bad for 2 reasons. We somehow have the tendency of letting the 4 grow larger than it should. And it ends up doing more than a thing. And of course, while is also bad. The problem is loops, right? Loops are bad because they end up doing too many things. Heavy complexity here, heavy complexity there. And if they do different things, for example, here, if they add to a list or compute a total, you should look into breaking the 4 into separate 4s, right? But now, if I ever see a 4, I saw it twice today in a code sample from the company that I trained at. If I saw a 4 that is preceded by an empty list being created, I know already what's going to happen. This is a new code smell today. This is an anti-pattern. Do not start a 4 after declaring an empty list, because what you're going to do in the 4, you're going to add to the list. And remember, a side effect, changes to data are bad. So when I just read this, I don't even have to look in the 4. I know what's going to happen. You're going to add to the list. And that, my friend, is an anti-pattern. So accumulator loop should be replaced with a stream, of course, collect, with a stream, sum, right? With a functional pipeline computing the stuff. So you see what happens in here. Sorry, I should mention also that in practice, in 18 years, I've only met 2 teams from hundreds that told me that this actually hurt their performance. And those 2 teams that I mentioned, they were working in the stock trading industry, and their response times were somewhere in the range of 50 microseconds. You don't do 50 microseconds response times, do you? Micro, not milli, micro. So unless you have a game like that, in which you have to respond from memory extremely fast, this breakdown of 4 will never hurt. I benchmarked, I tried, I asked around, never hurts. Okay, so that's the basics. You should not use for, you should use a stream, and that's what they do. The first set of smells here are, let's say, misuse of function programming. In Java, you can write orders.stream and you can use a filter. Then you can, yeah, ooh-ha, there you go. You went streams, bravo, you say to the junior. And then the junior ends up in doing a for each to compute the total of the orders. It does this. You see what I mean? Total plus equal. And it defines the total up above. Now, fortunately, the Java is the only language in the world which fails to compile this code. All the others, Scala, Kotlin, Clojure, C#, everything else, everything, Java. If JavaScript, everyone can do this. Java can't. Java can't change a variable living on the stack frame of the current running method. It cannot do that. It's something related to multi-threaded access. The point is, it will fail compilation, and people have long been cheating about that. Thanks to IntelliJ, who suggests with an option enter, alt enter, quick fix, which suggests to replace this, to fix this error by going to atomic integer, or by converting this int into an int array, for Christ's sake. Why would you do that? Because that moves the side effect, that moves the changes from changing a local variable to changing something on the heap. And changing something on the heap, it's no problem, right? So we've been cheating a lot. I've seen this in code today everywhere, but it's a problem basically induced by the quick fix that IntelliJ provided for a couple of years. Nowadays, today, however, IntelliJ came up with a better solution: avoid mutation using stream API sum operation. So it actually suggests this now, and if you alt enter, if you click that, it's gonna come up with the proper solution, which does not change. Rather, it returns. See the point? I'm returning, not changing. This is changing, right? So in other words, for each is a code smell. The code smell here goes a mutant pipeline. You start with a functional pipeline, but then you do for each or if present. Both of these two are returning you nothing, giving you void back, which means they have to do side effects. So don't do this. Don't do for each and then map put. Don't do for each and then atomic integer increment. Don't do optional dot if present, and if present then list add. Don't do none of this. Instead, use the solutions on the right here. You should explore these more if you want. You can do sum, you can do correct to map, you can do flat map, optional stream, all sorts of solutions for you to avoid changing state in a functional pipeline. Still, there are some cases in which you can't really avoid doing side effects. When the side effects go outside your system. You send a mail, you set a field, or you save in a database, right? If you have to comply with some mutable data model outside, okay, set the field. Hey, still I have to mention, if you watched the previous talk, he showed you a problem, a very common problem in Hibernate, or in general SQL, which is n+1 queries. The same would happen here in a form, because I'm going to send fire one by one each mail. That's not really smart. You should look for a method to send all the emails at once, right? All the emails in a single bulk, in a batch style, right? It's more efficient with network, right? Another thing that I've seen, people using streams and flat map and map, and getting, let's say, confused in the process. Like, I think that follows in the next one. Yeah, you're going to see this in the next slide. You get confused with the functional kung fu, and you don't realize you're doing network in a loop. Yeah, you're doing network repeatedly. It can get you distracted very easy. Right? So the key point I want to make here is that you should avoid side effects whenever possible in for each. Right? At which point someone in the back says, I'm fine, because I'm doing map. And in the map, I do this. Yeehaw. Folks, I'm not inventing these things. This is something I saw today. Map, a bit anonymized for protect the innocent. You see this? Map, card, arrow, card, set. What the heck is it? Set? Really? Set, right? Set and then return. What is this? Right? This is bad habits, basically. The proper way to do that really is using peek if you really want to do that. You could refactor this by saying not map, but you should do peek and then this, for example, right? Set the user alias, and then you don't need this here anymore. You can just do this, which is far better, right? I think I'm missing some types here. Set user alias, peek, filter. Actually, this is more interesting. If you want to see this in action, you should vote at the end to fight the mutant pipeline. So I hope we have time to actually dive in the code. There is another solution for the problem you're going to see. The idea is that side effects are bad. That's what I want you to take away. They're often necessary, but try to avoid them wherever you can. So that was the section about the functional programming misuse. In a nutshell, creating immutable objects carelessly, too large and fragmented, making excessive use of builders, and also doing unneeded, avoidable side effects in places that you could just instead return a value, not change some state. All right. Now, there is the other more fun set of code smells, which is from abusing functional programming. The famous one is this: functional chainsaw. Someone wants really to prove you that how wants to show off his skills in functional programming, and he writes an endless.
Somebody stop me!
Endless stream. This is not fun. It breaks the brain. It kills your brain. It's too much cognitive load in here, right? What you want to do when you face, and also very, very interesting, after all of this, no one really, if I leave you 5 minutes now, 3 minutes, none of you is gonna see that at the end, this code is actually doing a database call in a loop, repeatedly, for no freaking reason, really. So you can miss terrible bugs. I'm going to quote a technical lead that I heard today in the workshop. He said, I have a colleague in the group who's doing all sorts of functional kung fu like this, and every time I see this, I say to myself, he probably knows what he's doing. So his pull request comment was, looks good to me every time. Done. Because this is not brain-friendly code. What you want to do to this code is to start extracting things out, making methods out. Maybe you can wrap this into a method nicely called order is recent. Maybe you can wrap this little baby over here in a variable that you can explain what that thing means, which is ordered. Maybe you can define a variable which keeps this section in a list or something. You want to break down to, let's say, 3 or 4 dots. 1, 2, 3, enough. Don't change too much. But we are in Java. In other languages like Kotlin, there is a good practice to have as many functions you can, expression functions, which is just basically a function whose body starts with return. The more of these you make, the better. Now, in reverse, you've probably heard of reactive programming, in which they chain horrible reactive chains ad infinitum until their brain explodes. This is mandatory coding style, in order to ensure that you only subscribe once to this chain. Now, this is a mandatory way. Also, goodbye variables. It is a bad practice in reactive programming to keep variables of type publisher. It is a bad practice, with good reasons. I'm also into this reactive thing. So that's why we all hope that reactive programming is gonna die, thanks to virtual threads, Java 21. And also, you should never throw exceptions. You are not allowed to throw exceptions in here, only return an error. Oh, and one more. You need to learn 100 operators, approximately, in order to be fluent in reactive programming. Otherwise, you can do shitty code. So this is not clean. Although there are some best practices that that I can tell you more about in some workshops. But technically, reactive programming is by definition horror. All right. Reduce. Okay, you could say, this is TypeScript. We are Java developers. Why do you show us this? Just bear with me. I don't think any of us can survive writing code in a single language anymore, right? Whether the second is Python, Bash, or TypeScript, you should write. No one writes just a single language anymore, or SQL. The point is, this kung fu over here in the reduce starts with the previous and the current element, and jumps and dives into a very, 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 very horror expression. What the heck is deck? Wow, null safe traversal. What the heck is this? Oh, null coalescence. What the heck does GTE means? Oh, okay. What the heck is, oh my god, ternary. And for extra fun, the devil in person. This expression is killing, is shutting down. They try to solve the whole story in one line. What I tell them to do instead is to filter first, prepare the collection, massage the collection a bit, and then reduce it with a very simple expression, or maybe with a function that you've described before. Don't kill everyone with a super complicated reduce expression. Actually, that's just TypeScript, but if I were in Java, I would completely reject this pull request. What the heck are you doing in here? In practice, this can be reduced by using the max operator. This is what happens. If you give it 5 minutes to understand, this is what happens. They are picking that element in the list which has the greatest price, if it has a price. Technically, but this is TypeScript. You could say, wait, show us Java. This is Java. Reduce null, previous order line stream any match, and what the heck? Or mark. And when you see and then an or, every of our brains starts to bleed. And then at the end, ternary operator. What the hell is wrong with you? Don't do that. Prepare the collection. This same code can be written like this. Order string, filter. Order has premium product, which means this. Is there any order line that has a product premium? Is there any order line? You see what I did? I did object-oriented programming here. I put behavior inside. Then max comparing order creation they've done. It's 2 lines of boring code compared to the horror above, right? So try to keep your reduce. Actually, I would say avoid reduce altogether in Java. Do not use reduce. Reduce is just a bad habit of you coming from TypeScript, which they don't have, in which they don't have the max, these operators we have. Double-edged return. This is fun. It's both fun and dramatic. I'm going to explain. First of all, imagine a method which is very boring, which calls a method process, which is again boring, like this. And the method process, if the data name is blank, throws an exception. Boring. Yeah, not fun. But then one of your colleagues reads in one dark evening an anarchic article in which he reads about monads and about functional programming that should not throw exceptions. That in functional programming, you shall not throw. And without discussing with anyone else, they start refactoring the code. So when instead of throw here, they rewrite this to return a failed try. Not bullshit. This is a library from Java, very less known, Vavr, the former Java slang, right? Other languages have other forms of doing this. But you see, I'm returning something which carries along either the result or the failure, if any. However, when you do that in the method process, then the caller of your caller is gonna bleed, is gonna suffer. You're gonna pollute your caller. You're gonna force him to go from this simple boring code to terrible pipelines to you're gonna force it into a functional style. Do you want to do that? And actually, this pollution going from the caller into the from your method into your caller, we've seen that before, and it was called checked exceptions. We just got rid of those in Java. No one uses checked exception in Java anymore. Actually, these are a mistake. No other language in the world has checked exceptions. And we killed them because if I put a throw checked exception here, I have to repeat the same bullshit here, which is not fun. Right? I'm going to pollute. I'm going to leak my abstraction. I'm going to shit on my caller, basically. Right? So don't do that for technical errors. Consider doing that. It's more advanced and it probably needs more debating. Consider that in case you have a business outcome you want to communicate, in which case you could play with sealed classes for this reason. So the point is, try to avoid this idea, right? But you know what happens really? This is psychology. I see people doing this, almost always. People do this when they come from other more advanced language, more modern language, and they are forced to write Java. And they bring along with them the habits from other languages like Scala, Kotlin, or Go, right? And they bring in Java some practices that are not established in our language. So maybe go to therapy, but don't shit on our language, with all due respect. And I love Scala, and I love Kotlin. I can't say about Go, but these two, I love them. The same happens with Completable Future. Thank God they will rest in peace. They are dying, in case you did not know. Completable Future are not going to be here with us 5 years from now, thanks to virtual thread. Look, Google for Venkat Subramaniam, who explains it very nicely last autumn at DevOps Belgium. One more point here to make about optionals. We all know optionals. We love optionals. They are the Java's desperate attempt to get rid of null pointer exception. The idea with optional is that every function that may return nothing should instead return now an optional which is empty, right? Including getters of nullable fields in your domain model. if I have in your model some stuff which can be missing, you could just return an empty instead. Do not ever return null anymore. Illegal. Pull reject, pull request reject. No, don't. Not towards your business logic, at least. Never. However, you can abuse optional. You could see, I've seen several times, optional. I was like, what? Of list. And of something. What the hell is wrong with you? What do you mean optional of list? Don't you know that lists have their own, let's say, empty value? You can return an empty list instead. You are kind of doubly protecting. List can be empty. Why would you want to? It's very, very confusing for the brain. What difference is there between an empty and an optional carrying an empty list? You are confusing the brain. They both can carry nothing natively. An empty list or an empty optional. Don't do both, double wrapping. Also, don't take optional parameters into methods. This might be a sign that your function violates single responsibility. It does too many things. So you might want to start cracking your function into, maybe break that big function into, make an F and then a G. And you call G only if you need it, only if you really have a B to pass it. Maybe it's too dense for this moment of the day, but I think you can get the point. Also, then if you have a function taking an optional, just optional, maybe don't call it at all. Start from the optional and map over the function. So not as a parameter, because an optional parameter should lead to the question, does that optional parameter, should it really be there or should I break the function into, basically? That being said, I've seen optional parameters, it's not the end of the world. Right? Fields. We should avoid fields, but the exception is records that might want to have fields of type optional, or when a framework like immutables or Spring requests that. I'm going to share with you the slides afterwards. You can click on the links. Also, an interesting, this debatable point is when your method returns a careful optional to all its callers, but then all the callers throw on your empty. If everyone in your application throws whenever you return an empty, do you really want to return the empty, or would you rather throw yourself inside your function? Right? I mean, if, for example, user.get role. Would you imagine a user without a role in your application? Maybe you can, but if you don't, you could just have, when you try to access the role, and if it's not a role, you can throw exception, right? Or find by ID. If it's not there, we should throw. Right? So don't put optional everywhere. Put optional for the methods that have to return something, which sometimes is missing, right? It's a signal for the caller. One more way to break your brain is to dive too much into functions, to higher order functions that take and return functions. I mean, let's be honest. Taking a function in as a parameter is not a big deal, really. I mean, yeah, it's a piece of logic that you execute whenever you want. It's pretty okay. The game is completely different when you return a function. When you freaking return a function, you don't have a clue when your code is gonna run. You don't know on how many threads, on what thread, if it's gonna run any at all, in what transaction, on what machine. Welcome to InfiniSpan, or what's the name? Scala, Spark. You can ship your Lambda to another system to execute there. It's scary when you return a piece of logic. You don't know what's going to happen with it. It's hard to debug, hard to reason about. So try to avoid returning. There are good use cases for this. But it should be the last tool in your toolbox. Avoid doing that. It's a tremendous load for the human brain. Don't do that. So these are the smells, the new age code smells that I see rising in code. Now, if you can use chat, you can point me at which of these would you like me to show you some code about. I think we only have time for one of them. It's a couple of minutes left. So if you can use the chat, and if you want me to show you one of them, if not, I'm going to wait for like 5 seconds for you to pick. If not, I'm going to pick my own favorite and I'm going to show you. So 1, 2, please vote in the chat. 3 seconds. We have 1 single vote. We have to vote. For number 5, reduce Rodeo. Yeah, and we 5 wins. 5 wins. Reduce Rodeo. Right, let's play this game. So, order stream, reduce, null. Ooh. Previous order. And then And then try to squeeze this in your brain here. We have a long expression which doesn't do anything if this is false. If this is false, the not, let's try. If this were false, what does it do? Let's use IntelliJ to simplify this. What does it do really? False question mark previous. What the heck is this? Simplify. It's actually returning always the previous. So technically it will return me a null. It will not do anything. So that being said, with the help of IntelliJ, I can decide that this should actually be a prior filter in front of the reduce filter. Boom. Giving an order, give me let only the orders which have a, but then I could say, what the heck is this? This is way too complicated, right? Let me just make the code compile. Right. And the good news, I think we also have a test for this, carefully generated with Copilot, but I've manually checked that it's all okay. Right? So that logic over here is actually too complicated to my brain. Let's make a method. Has premium product. And then this method over here can fly away into the order. Boom. And then 4 dots. Thank you. Love. Good. Then what happens here? Well, if previous is null, what does that really mean? It means that the first element in the game is gonna be good enough. Right? If I have a previous, which is null, I'm gonna fall back to the order, which is the second one. So technically, this is the same thing as doing reduce. If you don't pass the first argument, that reduce is now returning you, let me close the parentheses, is now returning you an optional of order. But then you could say optional of order or else null. Don't judge. This is the code I found. Don't judge me. All right? It was returning null. I have to return null. Did I break any test? No. But wait a second. Nowadays, previous can never be null, says IntelliJ. And you can't argue with IntelliJ. I'm going to simplify this. Hey. This is better. What is this code really doing now? Let's understand one moment more. Is if you have the previous value in the reduce and the new value, if the new value, let's call it like that previous one, yeah. Then if the new value creation date is after the previous creation date, then the new one is good enough. So what is really happening in here? This, my friends, is getting the maximum. So this is actually max by comparing order creation date. Ta-da! Right? By using the proper operators, you can get rid of a criminal expression and make it much more readable. Right? This is what happens here. I'm maxing by the creation date. I mean, this was killing for the brain. What the hell is that? And this might be a bad practice of someone reconverted from TypeScript. Very easy. I mean, they don't have max, so they have to do such things. Right? But you need to use the habits of the language. Look how beautiful the code reads now. Right? So yeah, I think that would kind of conclude the idea. My time is up. So I would just want to invite you to join the European Software Crafters to keep in contact with me. We meet every month. For the talk next month is going to be about coding with empathy. About coding is actually a lot about human emotions and being empathetic with the reader, with the colleagues. And it will be an interview, a podcast, live stream with some interviewer. But we're gonna, you can join and ask questions and we meet every month. That being said, I thank you all. I was Victor Rentea. I have a website if you want to know more. Thank you very much, and I hope you enjoyed the conference and the discussion. Right, love to hear you more from you.